My dear students, in today's tutorial, I'll be explaining about the IUPAC nomenclature of coordination compounds. Let us consider this coordination compound. Cobalt, ammonia, water, chlorine, and outside the coordination sphere you have got Cl2, that is chloride ion. How to name this compound? So it is given clearly: tetraamine aquo chlorido cobalt 3 chloride. Now let us study how to name this compound. Now, first of all, when you have got such complex compound, you should be able to identify the type of complex ion. You have got here the complex ion is indicated by this square bracket. So now when it is ionized, this becomes plus and this becomes minus. So this is the complex cation. Complex cation. And you should remember that we should always start the naming with cation followed by anion. Suppose if it is a sodium chloride, NaCl, we start with sodium and it has a suffix IUM, sodium, then chloride. We don't call it chlorosodium. But in the case of complex compounds, the same convention is adopted, that is, we should start with the cation. So this is the cation. But how to name this cation? We know this one is chloride because we know BaCl2. This is barium and this is chloride. So barium chloride. For instance, BaCl2. Put X for this because we do not know the oxidation state of barium and we should know the oxidation state of chlorine as -1. So based on this simple algebraic expression, the neutral molecule has the oxidation state 0. Based on that, let us work out X plus 2 of -1 is equal to 0 means X minus 2 is equal to 0. X is equal to plus 2. So the barium oxidation state is plus 2. So similarly, we should be able to identify the oxidation state of this complex ion. Put -1 for this, and what about this? Let me put X here. Now we can work out, that is X plus 2 of -1. So the neutral compound should have the oxidation state 0. Therefore X minus 2 is equal to 0 and X is equal to plus 2. Now we know the oxidation state of this complex cation is plus 2. So let us mention this as plus 2. We have found out. And within the complex ion, we should be able to identify the oxidation state of the central metal atom. Let me put Y for this. We should know ammonia is a neutral molecule, it's a ligand, neutral ligand, so oxidation state is 0. And for water it is 0. And for chloride it is -1. So the ammonia, you should have the name amine. So you must remember that you should have 2M. So there are 2 M's when we name the ammonia. And how many ligands are there? 4 ammonia molecules are there. So 4 tetra. So tetraamine. That is over, is it not? And aquo means water. So aquo. And then chlorido, usually it's called chloride But in IUPAC nomenclature of coordination compound, that is within the coordination sphere, chloride should be called chlorido. So the final E should be converted as O. So when it is outside the bracket, it's chloride. But when it is inside the coordination sphere, it should be called chlorido. So chlorido has -1 oxidation number. So now we want to fix this. And when we name the coordination compounds, it should be followed by alphabetical order, and particularly neutral molecules should be given preference. So in that case, ammonia and water are neutral molecules. Among these, alphabetically AM comes first. Therefore, there are 4 amine, double M. So tetraamine and aquo, then followed by chlorido. Finished. So we are named the ligands first, followed by the, that is, central metal atom. Which is the central metal atom? Cobalt is the central metal atom, and we had to put cobalt along with the oxidation state. So for which we had to calculate the oxidation number of cobalt as central metal atom. Let us work out cobalt oxidation state. Here let us put Y, and there are 4 amine with oxidation state 0 and 1 water molecule with oxidation state 0, and there is 1 chloride anion, so -1. So that is equal to, the resultant oxidation state is +2 for this complex ion. So this is the way you have to follow. You know very well Y plus 4 into 0, 0, 1 into 0, 0, and 1 into -1, -1. So we can put -1, that is equal to +2. It means you can cancel all these things. So Y minus 1 is equal to +2. Y is equal to +2 +1. When -1 goes to the RHS, it becomes plus. So +3 is the oxidation state. So Y here is 3. You can put by the Roman letter 3, which is nothing but +3. So when you name the compound, now you can have this cobalt. Are you able to follow? Cobalt 3. We have named it. And then followed by chloride as such. Are you able to understand this? Okay. Now you should be able to derive the formula based on the IUPAC nomenclature also. So here we have attempted initially naming the coordination compound by IUPAC convention. Now let us try. Let us make it ulta like this, and we have to arrive at the exact molecular formula. Let us try to arrive at. Now take this tetraamine. You can write tetraamine, NH3. Amine means NH3, and 4 times tetra. And what is aquo? Water. So water is 1 time only. Chlorido, put Cl, right? And cobalt, put cobalt. And what is this oxidation state? 3. So put +3. And the chloride. So outside the coordination sphere, it has Cl. But we want to fix the oxidation state of the complex ion, and then only we will be able to arrive at the complete molecular formula. So this is plus, and this is 0, and this is 0, and this is -1. So in that case you have +3 and -1 means +2. So the resultant is +2 oxidation state. If it is +2, we know already this is -1. So it means we should get the, that is neutral compound. So this is plus charge, this is +2, this is -2. So this should be multiplied by 2, and that can be taken as the what? That is atomicity. So finally you can write the name like this. Are you able to follow? So once you have mentioned, and you can rewrite also, okay, better. Once you have arrived at the molecular formula, eliminate, that is remove all the charges, so that it should be totally clear from the oxidation state and declaring that it has the neutral oxidation number. So cobalt and then NH3 4 times water Cl bracket Cl2. So tetramine, aquo, chlorido, and cobalt 3 chloride. So this is the way you had to arrive at the compound molecular formula based on the IUPAC system. Okay. So thank you very much for watching this video.